Hi, it's Mr. G here, and today we're going to be looking at price elasticity of demand and price elasticity of supply. So we've looked at in previous chapter all about supply and demand, different uses for the model. We looked at labor, financial markets, etc. So now we're looking at price elasticity and what that means. Well, let's just have a look and see exactly what price elasticity means. So if we look at demand and supply looks at the relationship between price and quantity demanded supplied. So that is what basically demand supply looks at. Price elasticity looks at both price and quantity demanded, quantity supplied, but it focuses on something different, the percentage change or the ratio. So how much in percent does one change given the other one changes? So how sensitive to basically price changes is basically whatever the item is. And I often would in class hold a rubber band and I would stretch it out. And if you think about it, price changes, you can have a very big response. The rubber band's fully pulled out. Or you might get a very small response where the rubber band doesn't move a lot. And so that's essentially what we're looking at. We're looking at how responsive demand is going to be, or supply, quantity demanded, quantity supplied, versus price changes, okay? And to do that, we're going to have to basically go over a formula. So I have here price elasticity of demand, percentage change in quantity demanded over percentage change in price. And so I have there, the triangle is basically representing change, percentage change. QD is quantity demanded, percentage change in price. So that's the top one. And then the bottom, percentage change quantity supplied, percentage change in price. So those are essentially what we need to calculate out in order to do this. And we'll go through a little bit more in the formula in a moment. So if we look at it, we calculate it out, we'll get a number, and we'll go through an example with it. If that number is greater than 1, we say that it's very elastic. For every 1% change in price, you'll have over a 1% change in quantity demanded or quantity supplied, depending which one you're calculating. For unitary elasticity, every percentage change in price will have an equal amount percentage change in quantity demanded, quantity supplied. And within elastic, it should be less than 1, not very responsive. The percentage change will be less than 1 for every percentage change in quantity demanded, quantity supplied for price, okay? So it's basically what we're looking at, and we have to remember to take the absolute value, but we'll talk about that a little bit later. So let's go into the midpoint method. So the midpoint method is what we use. For AP Micro, you might have learned a easier format, one that doesn't require as much calculation. But the midpoint formula is typically what is always used, almost always. The only time I know that they do different is sometimes AP exams, just because they don't have a calculator and it makes calculations easier. You will need a calculator for this kind of a formula, just because often there's a lot of calculations involved. But this is the more accurate and the better way to calculate it, so we use the midpoint method. So you can see I have it here for quantity demanded. Percentage change, quantity demanded, percentage change in price. Well, this is what I have in this formula right here. So I'm doing Q2 minus Q1. What are those? Well, the quantity 2 minus the first quantity. So we were talking about a change. We're looking at how much is quantity changed. On the bottom, Q2 plus Q1 divided by 2. What are we actually doing? We're actually just figuring out the average. That's how you figure out the average. How do you figure out the average of 1 plus 2? Or 1 and 2? You would go 1 plus 2 divided by the number of numbers you have, which is 2. Well, that's what we're doing here. We're just figuring out the average. So on the bottom of both for quantity demanded and for price, all we're doing is we're essentially figuring out the average. So it looks a little bit more complicated, but it's actually fairly easy. So we're just minusing the quantity difference, okay, and dividing that by the average, okay, and that's why they say midpoint method, okay. So we're taking the average of the two amounts and we're dividing by that. And same with price, we're taking the first price minus the second price. Remember, for demand, one of these is going to be negative. It has to be. For supply, both of them will be positive. or both of them could be negative, which would then make them positive. So, and it doesn't really matter the order, which one you put as quantity 1, quantity 2. That really doesn't matter because it will work out in the end. Just depends where the negative will be, but we take the absolute value anyway, so it should work out correctly no matter which way we put it. Some people get confused that in, say, elasticity is the same as slope. It is not the same as slope. Elasticity is not equal to slope. Slope is rise over run, and you can calculate that at any point. Elasticity, we're using our midpoint formula, and we're calculating the percentage changes given, certain points. Okay, so let's have a look at an example. And maybe it'll make things a little bit more clear on how we do this. So I basically have an example here. The market is a cup of coffee at a local coffee shop. They're going to be they want to know how much, how responsive, how much demand are they going to lose, given that they increased their prices from $1.50 to $2. And you can see for a business this matters because, if a price increase isn't going to cause a lot of demand to basically go away, then essentially what's going to happen is, they can keep raising prices. If you have a product that's very sensitive to price, that as it goes up, the demand quickly drops off, then essentially, you have to be very careful in raising your prices. So knowing elasticity becomes very important. So if we look at this example, we have price change. So we have $1.50, and the price is then going up to $2. Okay. And as we know with demand, the law of demand, it basically states as the price goes up, quantity demanded will decrease. And that's exactly what we have happening here. We have the quantity demanded going from 50 to 40. This is why when you figure out elasticity for demand, it will always be negative, and then we have to take the absolute value of it. So we've increased our price 50 cents, and the quantity demanded went down by 10 cups. So they sold 10 less cups. So let's have a look, and let's plug this into the formula. So you can see we just did 40 minus 50. We're just doing, remember, percentage change in quantity demanded divided by percentage change in price. So we're just taking the quantity demanded, 40 minus 50, up in the top. Right below it, we're just figuring out the average. How do you figure out the average? You add the two numbers together and divide by the total numbers that there are. So if we're adding three numbers together, we divide by 3. But in this case, we're just dealing with 2. So we're doing 40 plus 50, which is then 90, divided by 2, which is what I have here. So 40 minus 50, negative 10, divided by 90, divided by 2. And then at the bottom, we're dealing with the price. So now we're doing 2 minus $1.50. And then we're just figuring out the average at the bottom. 2 plus $1.50 divided by 2 again. And so we got 0.50 divided by 3.5 divided by 2. Okay, now we just got to keep solving for it. And you can see 90 divided by 2 is 45. 3.5 divided by 2 is 1.75. And then we start dividing it. So we do minus 10 divided by 45. We come up with 0.2222 repeating. On the bottom, we do 0.5 divided by 1.75, and we have 0.2857. Divide those again. We will come up with a negative number, and our final number is 0.77. So what does this actually tell us? Well, first of all, people are like, well, it's less than 1. And it would be anyway in this particular case, even if you took the absolute value. But sometimes people get an answer like 1.54. And they'll say that's inelastic because it's negative. Well, every time you figure out for demand, the price elasticity of demand, essentially it will be a negative number. So you have to take the absolute value. So if you were to get an answer like 1.54 or negative 1.54, we would just take it as 1.54, which would mean it would be elastic. It's greater than 1. All right. So same with this, 0.77. We count it as 0.77 without the negative, so just positive. But that number is less than 1. So if it's less than 1, it means it's inelastic. If it was 1.23, it would be greater than 1, so it would be elastic. If it was equal to 1, it'd be unitary elastic. And so, but with this case, we know it's inelastic. What does that mean? Well, remember, it can always be written over 1. So the 0.77 can always be written over 1. Any whole number can be written over 1. What is 5 equal to? 5 is equal to 5 divided by 1, because that's still equal to 5. Why is that important? Well, remember, we're looking at a ratio. So the top part tells us the percentage, and the bottom part, if we know that's 1, so we know a 1% change in price, because we have 1 on the bottom, in this particular case will lead to a negative 0.77% change in price, in quantity demanded. Okay, so as price goes up, quantity demanded will decrease by 0.77%, and vice versa. Remember, people are like, well, why do we have the negative back again? I thought we'd take the absolute value. The absolute value is to determine whether it's greater than 1, less than 1, or equal to 1. But when we're talking about and putting it into a ratio, you have to remember that as one goes up, the other will go down. And so the negative represents that. All right. So a 1% increase in price in this particular example would result in a decreased quantity demanded of 0.77%. Or vice versa. A 0.77 increase in quantity demanded would result from a 1% decrease in price. Okay, so if you want to sell more, you know how much you'd have to decrease the price, etc. So that is what it means. And so that's basically how to use the formula. Obviously, it takes some practice, and you just need to practice the midpoint method. But once you get it, it's actually fairly easy, and it's fairly easy to calculate. It's just a lot of different calculations. All right, and so in the next section, we're going to be going over how to graph this. Graphing becomes very important with elasticity, and basically knowing, being able to interpret a graph and telling whether it's inelastic or elastic just by looking at a graph. But that'll be in the next section. That's it for 5.1. This is Mr. G. Bye for now.